Hello, have you ever solved this question? Second derivative of y with respect to x. Have you? Okay, if you have not, or if you have forgotten the concept, let's go together. Here's the solution. Here's the solution. We have been given y is equal to sine of x divided by x. Some sort of quotient rule supposed to be applied here. Let's recall the concept of quotient rule. It says that if you differentiate two functions of the form u and v, where u and v are functions of x, this one equals to v, then du dx minus u dv dx divide by v squared. For this particular case, our u will be equal to sine x, and our v will be equal to x, such that du dx is equal to differentiating sine with respect to x. Here we shall get cos x, which is a positive. Differentiating v with respect to x, this one gives us 1. So let's substitute these values into this. So we shall say the derivative with respect to x of sine x divided by x, this one will be equal to x derivative with respect to x of sine x minus sine x derivative with respect to x of what? Of x divide by x squared. Okay, we got the respective values. Derivative of sine, you said, is cos x. So here we shall have x cos x, yes, minus differentiating x with respect to x, that is 1. So 1 times sine, this will become sine x. Then we divide by x squared. So our dy dx equals cos x over x minus sine x over x squared. This is our dy dx. Now we have to take the second derivative of this, the whole of this one, so as we can get that d squared y over dx squared. Differentiating both sides with respect to x, this one now becomes the derivative with respect to x of our dy dx equals the derivative with respect to x, the whole of the right hand side, which is cos x over x minus sine x over x squared. This is what we got. Differentiating derivative of y with respect to x again, this is what we get. The second derivative of y with respect to x will be equal to differentiating with respect to x. Let's take the first portion, which is cos x over x. Then there is minus sine, the derivative with respect to x of sine x over this side is x squared. The right hand side is retained. Then the left hand side is retained. The right hand side is what you can write. We have quotient, so we go back to reapplying the quotient rule again for each function. Here we have function cos x over x. Here we have function sine x over x squared. So applying the quotient rule, the one we stated before, here we shall start by writing x, then the derivative with respect to x of cos x, then minus, I'm still dealing with this part, then minus, it will be cos x, the derivative with respect to x of x, divide by taking x squared, we get this, then plus, oh sorry, not plus, that's minus, now let's take the derivative of this one. We use the square bracket to distinguish them. So minus, let's have the second bracket after minus. Now we have this time around our v is x squared, so we write x squared, we differentiate sine with respect to x, we minus sine, then we differentiate with respect to x, the x squared, then we take the square of the denominator, which is x. When you square it, we get x power 4, so this is equals differentiating cos, get negative sign, so it will be negative x, then sine x, then minus differentiating x, we get 1, so it will be minus cos x, divide by x squared. This is the first part of our differentiation. Then minus, the second part is where we have the square bracket, there's minus sign outside. Differentiating sign, this one gives us cos, so it will be x squared, then cos x, then minus differentiating x squared, this gives us 2x, to x, then to be sine x, divide by our denominator for the second part is x power 4. X power 4. So this equals, okay, let's put these terms, each one should stand on its own. So the first one will be minus x sine x divided by x squared. This will give us minus, I will have minus sine x, I will divide by x, because one x we have cancelled with that x on the numerator. Then minus, this one is cos x over x squared. Then we have the minus again. Now let me remove the square bracket because we're finished differentiating. Here we have x squared divided by x power 4. It will be cos x over x squared. Then we have one x here. Minus, this one will become positive. It will be 2. Then sine x divided by, this will become x power 3. Because one x we have cancelled with this x on the numerator. So this is what we have for our dy dx. This term is the same as this one, so we can collect like terms. So therefore, the second derivative with respect to x, this one gives us, we have minus sine, which comes first, sine x over x, then minus, these ones, there are two of them, so we shall say 2, then cos x over x squared, then plus twice sine x, but this one has x cubic on the denominator. Okay, so now we have, look here, now we have the second derivative of y with respect to x, and here we have the first derivative of y with respect to x. Now we have to go back to our equation and see what happens if we substitute the dy dx and the second derivative of y with respect to x in our original equation and see if we get the actual value, which is 0. Okay, remember the answers we got for the second derivative, these ones, the first derivative is that one. So let's now substitute our values into this. So what we're going to do, we are going to take the left hand side. Taking the left hand side. Let's take the left hand side. Taking the left hand side. Our second derivative, look here. We got that dy dx, we have negative sine x over x. Then minus, this is the second derivative, twice cos x over x squared, then plus twice sine x over x cubic. Okay, this is our second derivative. Then plus our first derivative. Before the first derivative, there is 2 over x outside. So let me put it here so you can see it clearly. So there is 2 over x. Then our first derivative, we got cos x over x. Then minus sine x over x squared. This is our dy dx. Then we're supposed to add. What are we adding? We are adding y. What is our y? Y is sine x over x. Okay, now let's simplify. So here on the numerator, okay, the formats are different. So we shall have sine, look here, sine x over x. Let's add to it the y, which is also sine x over x. Then there's this minus, it's minus 2 cos x over x squared. Do we have another cos? Yes, this one, when you multiply this one, remember the sign here is plus, so it's plus. Another one is 2 cos x, x times x, this is x squared. Then plus minus, it is minus, this is 2 sine x, x times x squared gives us x cubic. Then, oh yes, we also have x cubic, which is positive, this one here. So we add to it 2 sine x, x cubic 2. So all terms are there. We have 1, 2, 3, 4, 5, 6 terms, which are 1, 2, 3, 4, 5, 6. So all terms are there. So minus sine x over x plus this one gives us 0. Minus 2 cos x over x squared plus 2 cos x over x squared. This one gives us 0. Then we have the minus sign, which is this one. Minus 2 sine x over x cubic plus 2 sine x over x cubic. This one also gives 0. So in other words, 0 minus 0 minus 0, this one gives 0. So what's the conclusion? Can you say therefore, if y equals this, then the second derivative the second derivative plus twice over x dy dx, then plus y. This one gives us 0, hence shown. This is our answer. Put your comment down there, give us a like. Thank you, and see you.